This video is on graphing linear inequalities. The graph of a linear inequality in two variables is the set of all points that are solutions to that inequality. The equation related to the inequality defines a boundary line, and the inequality symbol determines the half plane that represents the solution. Let's take a look at this diagram here. So the boundary line is the related equation to the inequality, and then the solution is either going to be this half plane or this half plane, which is going to be determined by the direction of the inequality symbol, whether it's a less than or a greater than. To graph an inequality in two variables, we want to graph the related equation and determine whether the boundary line is solid, and that would be if it's a less than or equal to or a greater than or equal to symbol, or is the boundary line dashed, which would be a less than or a greater than. Then we want to test a point to determine which half plane should be shaded, and then shade the half plane that contains that solution. So let's take a look at a couple examples here. Here we have the linear inequality. X minus y is less than 3. So I want to graph the line x minus y equals 3. But in order to do that, I need to put this into slope-intercept form. So I'm going to subtract x on both sides, and actually I'm going to leave it as an inequality here. So subtracting x on each side gives me negative y is less than negative x plus 3. And then I want to get rid of that negative y, so I want to divide everything by negative 1. And recall that when you divide an inequality by a negative number, the inequality symbol changes directions. So now what I want to graph is the line y equals x minus 3. So negative 3 is my y-intercept, and my slope is 1, so that means up 1 and right 1. I'll go ahead and do several dots here, and a few in the other direction. Okay, and since this is not an or equal to, that means my boundary line is going to be dashed. So I'll just put little dashes between my dots. Now I need to figure out which side of this line I'm going to shade, which half plane. Am I going to shade above the line or below the line? So I want to test a point, and the easiest point to test is the point 0, 0, the origin. As long as the line, your boundary line doesn't go through the origin, you can use that point. So testing the point 0, 0, I'm going to go back to my original inequality, and is 0 minus 0 less than 3? So when I put 0 in for x and 0 in for y, is this true? Is 0 less than 3? Indeed it is. So that means that the half plane that contains the point 0, 0 is the solution. So I would shade this whole side of that line. Another way to think of this is if your inequality is written in basically y equals mx plus b form. You're looking for where is y greater than x minus 3, and where the y-axis is greater than that line is going to be up here above, and that's what you would shade. It says then identify one possible solution. Well, I'm not going to choose 0, 0, I know that one is, but I do know that any point in this shaded region here is, so I'm just going to pick 1, 1 because 1, 1 is in that shaded region. Any point down here, so let's say like negative or 5, negative 5, would not be a solution because if I put that into here, it would not make that inequality true. And let's try this one here. 2x plus 3y is greater than or equal to 18. In order to graph this, I want to put it into slope-intercept form. So I'm going to subtract 2x on both sides. Oops. I was making that an equation. Let's keep it an inequality. 3y is greater than or equal to negative 2x plus 18. And then dividing everything by 3. And notice I'm dividing by a positive 3, so I don't have to worry about flipping my inequality. Y is greater than or equal to 2/3 x plus 6. So let's go ahead and graph that boundary line. So my y-intercept is 6. And my slope is negative 2/3. That means I'm going to go down 2 and right 3. Or up 2 and left 3. And since this is a greater than or equal to, I know that this is going to be a solid boundary line. So I draw a solid line. And I'm going to go ahead and test a point. I'm going to test the point 0, 0. So when I plug in 0 for x, I get 2 times 0 plus 3 times 0, 0 for y. Is that greater than or equal to 18? Is 0 greater than or equal to 18? It is not. So that means that the part of the line that the side of the line that contains the point 0, 0, it does not work, so that should not be shaded. So that means I want to shade this region up here. So all of this up here would be shaded. And that makes sense because when I wrote it in what looks like slope-intercept form, I'm asking myself, where is y greater than or equal to that line? It's going to be above that line. And a point that works, I'll just take an easy one. I know this point out here, the point 10, whoops, the point 10, 10 is one solution to that inequality. So in this video, we took a look at how to graph linear inequalities in two variables by graphing the related equation and then deciding whether that boundary line is going to be solid or dashed, and then testing a point and shading one side of the line. Remember that that shaded area means that every point in this region is a solution to this inequality.